One of the most vital resources for us is water. It is a major natural resource that we need in order to survive.
The NASA developed Mexico Water Management Team, constructed of 2 teams located in Wise County, USA, and in Saltillo, Mexico, utilized remote sensing to determine total water storage in the Rio San Juan watershed by analysis and comparison of modeling groundwater storage using in-situ measured data and GRACE satellite estimates. The Rio San Juan watershed, covering 34,000 square kilometers, is a major tributary in the Mexico portion of the Rio Bravo hydrologic region. The majority of water used in this region is used for agriculture, and users self-report how much water is used. This has caused a concern for water shortage in the area. The increasing water demand for domestic, industrial, and agricultural usage has stressed the current supply, and severe droughts continue to exhaust the region's known reserves.
Por eso la Comisión Nacional del Agua tiene la red tanto de saber cuánto requiere como también cuánto se explota, cuánto se extrae, y llevar a medidas de restricción de explotación del agua cuando la extracción o la demanda o el uso del agua excede o se acerca al volumen disponible.
For this project, we calculated the change in total water storage by using the GRACE satellite data. Once our data was obtained, we processed each file to ArcMap 10 and then clipped the data to our study region to obtain monthly values of total water storage.
To ensure that GRACE was adequately measuring total water storage in the region, the GRACE estimate was compared with an independent water balance equation. The water balance equation measures total water storage by calculating the difference between water entering the basin in the form of precipitation and water leaving the basin in the form of evapotranspiration and river discharge. This graph shows the total water storage anomaly estimated by GRACE, as well as the total water storage calculated using the water balance equation with in-situ and trim precipitation datasets from January 2002 to October 2010. We found that the total water storage fluctuations are fairly similar, with the exception of a spike noticed in November 2003 from our in-situ measurements. Good agreement between GRACE and the water balance equation allows for GRACE satellite data to be used to calculate the change in groundwater storage for this region.
Once we had our change in total water storage, we then calculated the total groundwater storage using a simple equation. For this calculation, we compared GRACE data with trim precipitation data, in-situ measurement, and soil moisture data from the GLADIS NOAA 1 model. Our soil moisture data, like the GRACE data, was processed in ArcMap 10 and clipped to the study area. As you can see, only 8 pixels cover our study area. To determine which results would be the most accurate, both 8 and 4 pixel values were used for data analysis.
It was determined that the groundwater storage calculations were sensitive to the soil moisture data. The 8-pixel soil moisture data represented an increase in total water storage, when the 4-pixel data showed a decrease in total water storage. Along with this, our in-situ data was showing a decrease in total water storage as well. This could be due to the limitations in spatial resolution from the GRACE satellite and the soil moisture data from the GLADIS NOAA 1 model. Both datasets are processed in a 1-degree format, whereas TRIM data was processed in a 0.25-degree format.
This graph represents groundwater storage using the 8-pixel soil moisture data. The 8 pixels were used in this calculation are shown on the right, outlined in red. As you can see in the graph, with 8 pixels of soil moisture, the GRACE satellite shows an increase in total change in groundwater storage, whereas our TRIM and in-situ measurements were showing a decrease in storage. Because of the differences in the spatial resolution, we observed 4 pixels of soil moisture instead.
When we used only 4 pixels of soil moisture with the groundwater storage calculations, we determined that there was a better agreement between GRACE, TRIM, and the in-situ data gathered. The 4 pixels that we used for this calculation is shown on the left, outlined in red. In conclusion, we have determined that overall we are seeing a depletion in the groundwater storage in our area. In future work, we plan to validate our GRACE calculations with in-situ groundwater measurements. Our final results will be transferred to our project partners to provide a better understanding on how to utilize remote sensing and in-situ measurements to determine groundwater fluctuations. This knowledge can influence policymaking in our study region and water management practices worldwide.
We would like to acknowledge the following. For more information on DEVELOP, visit our website at develop.larc.nasa.gov.